Welcome back, everyone. So, the journey to those mass distinction continues. So, this is how we actually continue. In this video, I'm just strictly going to be giving you a lot of theory. So, this is just one video of which I feel like you need to watch it over and over again so that maybe you can get the concept. So, in this video, I'll just be giving you a lot of theory. But I assure you that theory will not actually go to waste, because like it will actually help you in a lot of ways, because simplification is really being used a lot. So let's just jump straight into it. So what you'll actually be having in theory, you'll be having some sort of something like this, and then you'll actually have to put it in some sort of way of which is in brackets. Then why would you want to be doing that? Let me just give you some sort of like an example of which part I think you'll actually meet it while you're doing functions. If maybe just say you've got this thing and then you equate it to 0, you'll actually make sure it's supposed to be equals to maybe y. Instead of this y, maybe say y is now equals to 0, and then in that way you'll actually see that you can't really get much information. But if you actually put it in its factored form, actually we'll find maybe the intercepts. In this case will be the x-intercepts, and well y is 0. So this is one of the ways of which like factorization will actually be required instead of simplification. So if something is it's actually being put in its simplest form, you'll actually have to factorize it to get more information. So how do you actually factorize? The thing that you need to consider the most is actually the power, the highest power. So the highest power will actually tell you that you can use the following guidelines, but do not stress. If maybe something is into a higher power, let me just say 3, 4, it doesn't really mean that you can't use this. It just simply means you can't use it directly. You just have to first put it down up to maybe to the power of 2, then you can apply the guidelines that I'm gonna give it to you. So the next thing that you'll actually be working with is the sign in between that of this to the power 1 term. Since x is not specified, anything that's not specified, it is assumed to be 1. So this is the sign that you'll actually be considering. This sign will be the sign of the largest multiple. Which largest multiple? Maybe just say if you've got 2 multiples here, then the largest will actually get this actual sign. So if it's negative, the largest will get the negative. So this sign can either be the same or different depending on the other sign. Which is the other sign? This is the other sign. So if this is actually a positive, these signs are going to be the same. If it's negative, they're actually going to be different. But I'll actually show you what I mean as we proceed. Then the next thing that will actually be important will be this sign. As I've actually just told you, it will tell us if the signs inside the brackets will be the same. So we're going to be opening 2 brackets, and those brackets will be the ones that which like we actually mean by saying things are factored out. And then it will also tell us to add or subtract for the middle term. So there's something we'll actually be doing that we'll be wanting for the factors of this thing that will actually add to get this one. But as I promised, we'll actually discuss these things. I just want to show you the important bits of a polynomial, or maybe just say anything that is raised to the power of 2. Then the next things which are actually closely related is this term and this term, and these 2 terms combine to tell you what to put in the bracket. So I think right now I should actually dive into the other theory. So here's what you'll actually be doing. You will actually be getting something like this. So like let's just say here it's a 1 because it's not specified. So what you'll be doing here is to be putting the coefficients of x squared. What are the the coefficient of x1 is 1. The coefficients, the multiples of the coefficient of x squared. So what are the multiples of 1? So you can actually get 1 by saying 1 multiplied by 1. So you'll actually put a 1 here, you'll actually put a 1 here, and then here you'll get the multiples of the constant term. So what is the constant term here? It's also 1, so it's 1. So what we're actually looking for is, so you'll actually look for a combination of this thing that will actually give you this term. So what's that? If I say 1 times 1 since it's a plus, we need to add. So it's 1 plus 1 plus 1. So actually it means like this will actually be looking like our two brackets. So this sign will actually tell you if the signs are the same. This sign actually tells you two things. If it's positive, it tells you that the signs in the bracket are the same, and you add to get your answer. So this is where I actually added 1 plus 1 equals to 2. Let's say it was negative, I was going to say 1 minus 1. As now I have actually explained this thing. And then these are the signs of which are going to be different depending on these two. So let me just try to make it actually more clear. So the first thing that you'll actually need to do is just say, since this thing has got 1 and 1 as brackets, as I drew you that thing, it was just 1 1 1 1. So this is what I actually did. So in a way I've actually say it's 1x, because it's not just x but it's x squared. So it's 1x and 1x. I just took the constant term. So now that I know that I've actually opened two brackets, I need to start filling it in. So this is the part where I start filling it in. I put the other ones, as you've just seen in the previous slide. This is actually where I get the 1. Then the next step for me will be actually get the sign. So as I told you that this sign will actually tell you if these signs that are inside the bracket are supposed to be different or the same. So since it's going to be positive, it's actually telling you that these signs are going to be the same. So what I actually did here, I actually had that x and 1, but because of that positive sign, it actually tells me that these things are supposed to be the same. So that's why I actually have x minus 1, x minus 1. But x minus 1, if you just maybe say let x minus 1 be equals to y, so y times y is equals to y squared. So this is again something of which, like, you multiply something by itself, and then it actually means you can further factorize it or maybe simplify it, and then you'll get your x minus 1, which is actually all squared. So in that way, actually you'll actually factorize this thing, and then you'll actually put it in its simplest form. So whenever something is in this form, if you maybe just say equate it to 0, it is actually much easier to find the square root of 0 because it's 0. Then you'll actually have to solve for x minus 1, and then you'll actually get your information by saying maybe x equals to 1. So that's actually how simplification will actually help, factorization will actually help you in the future. So now that I've actually concluded the theory of factorization, I'll just give you more and more examples to actually help you understand factorization more. Enjoy the rest of the day. See you for the example.